Okay, there we go. Welcome. We're now with the Seestar in Texas. It's looking for M79, which is a globular star cluster in the south. To the south, it's about like 30 degrees above the horizon right now. And okay, we're looking at a live view there of the telescope in Texas. It's taking its first 10-second exposure. In a minute here, we should see some stars start to resolve on the screen. There you see some images there that are some stars that are trailing. It's right now still moving and trying to center this globular star cluster. These are globular star clusters are groups of stars. There are sometimes hundreds, thousands, millions of stars packed together very tightly, and there are some of my favorite targets in the night sky because there are many of them, and they have a lot of light on them, so that it's easy for the sea star to capture them. You can see them, or the sea star can see them very clearly, as opposed to faint nebulas or faint galaxies. The star cluster is a pretty easy target. You can start to see it resolve here off center from the screen there. And then, and then we've got the Seestar here in Miami on the Seven Sisters star cluster right now. These are the main stars. If you look at it, you could see it kind of looks like the Little Dipper. The Seven Sisters is often confused or referred to as the Little Dipper. I used to call it the Little Dipper because it does look almost exactly like the Big Dipper, but a much smaller version of the Big Dipper. And a lot of people do get it confused. But no, indeed, this is actually the Seven Sisters star cluster, or the Pleiades star cluster. Very famous target, one of the top, I would say probably top 10 targets in the night sky. Right now, this is almost directly above us. And these stars are very young stars. As we let the sea star sit on these stars and start to image these stars, you'll start to see a haze around the stars. I don't know if you could see my mouse moving around some of these stars. These bottom three will have a haze. If I let it sit for another 10 minutes or so, you'll start to see like a little nebula, a little cloud around it. And these stars are very new. They're babies. Basically, they're about 2.5 million years old, which is a very long time, but in star life is actually very young. That's like the equivalent of a 3 month old newborn baby. 2.5 million years for these stars. So this is the star cluster of the Pleiades, and we can see that it's referred to as the Seven Sisters. I mean, right now you can count one, two, three, four, five, six, and then seven right here. So these are the main stars of the Pleiades. There are many other stars in the background that are much smaller, that are not part of this star cluster, the Pleiades or the Seven Sisters. But the main ones here are the ones that are included in the star cluster. And I've photographed this cluster many times. It's a beautiful cluster. I've let it sit there for 4 hours and get really sharp images of it. And the haze around the main stars will start to show a blue haze around it, which is very beautiful, very very rich blue. And it's starting to come in now a little bit. If you can see there's a little cloud, like a little kind of like a dust cloud around these here. Those are the main stars at the bottom here. They're going to show the nebulosity. Meanwhile, let's go back to the telescope in Texas and see where we've got over here. Okay, we've got the M79 globular star cluster. I'm going to zoom in a little bit, and you can start to see a little bit of it there. It's kind of faint, but that's a globular star cluster. Let's see, the M79. There's many of them. There's actually over 100 of these that are very visible in the night sky. You can even see these with a regular visual telescope. But we've got this star cluster going on here. Well, we've got the Pleiades here in Miami, and this view from Texas is my second remote telescope that's in Texas, in Brady, Texas, at a place called Star Front Remote Observatories. And we can zoom back out a little bit. And this telescope is housed in the middle of the desert. Really, this company has set up a remote observatory in one of the darkest areas in the United States. It's a Bortle 1 night sky. There's a Bortle rating to measure how much light or lack of light there is in any particular area of night sky. Uh, Cities or towns close to cities are usually in the higher spectrum. The scale is from 1 to 9, 9 being the most light polluted area, like say downtown Miami would be a 9. Out in the Everglades, like say at Flamingo and Everglades National Park, that's bordering between a Bortle 2 and a 3. It's very dark. And I've been out there and I say to myself, wow, it can't get much darker than that. And it actually can in Texas, where my second telescope is. It's in a Bortle 1 night sky. So that is some of the darkest night sky in the United States and in all of North America. It is about 30 miles away from the nearest town. There's not much out there. Basically, this company has uh, selected that area for the dark area, the fact that it's away from the city, away from any towns that don't reflect any light. There's no light pollution. You could, they say you can't even see your hand in front of your face when you're standing out there at 11 o'clock at night. It's that dark, and any little light that is there will show up very brightly because it's so dark. Your eyes, when you're in a dark area like that, to really adjust to the darkness of it. And you ideally want a telescope if you're going to be doing astrophotography and visual observations. You want it to be in the night, in the darkest area possible. And in the United States, places like national parks out in the desert, like like in Death Valley, places that are far away from city lights. That's where you're going to find the darkest areas. They're hard to get to. There takes time, takes money to travel to these areas. For the longest time, I've been traveling to dark areas. We'll go back to the Pleiades while I'm talking about my adventures in astronomy and astrophotography. Riding out to the Everglades is kind of a common thing that astronomers here in Miami do to get away from the city lights. In fact, yesterday, Ann and I, we drove out to Shark Valley. There was a star party at the Shark Valley um, Visitor Center, and unfortunately, it was very cloudy. But that's about 15 miles away from the like I said, the most western part of Kendall. And still, when you look towards the east from Shark Valley, you could see the glow of the light to the east. If you look towards the south or the southwest, it's very, very dark. So that's a place where if I'm going to image, and I don't want to go that far, like out to Big Cypress, and I'm going to image something in the west or the south, that's an area that I would go to. Shark Valley. Excuse me. Last night we had a star party that was actually sponsored by the Shark Valley. It was with an association with my astronomy club, Southern Cross Astronomical Society, and we had a few people go out there and set up the telescopes. Even though we knew the weather was not going to be that great, we still set up, and we were able to see Jupiter and Venus, and that's about it. It was not the best night for imaging on there, but it was a lot of people came out. They did some tours, walked around, tried to spot some owls in the night, and actually had some telescopes set up at the observation tower at the end of the trail. But the reports were they were not able to see anything because it was so cloudy. Tonight, it's very clear in Miami. It's very clear in Texas. In fact, I'm going to go to right now to the website so you guys can see what Star Front actually looks like in Texas. We've got a window here. I'm going to go to Star Front, and it's starfront.space is their website. Dark skies made easy. This is where my telescope is housed. You can see all these telescopes. This is an amazing place. They've only been open 6 months, or actually since June, about 8 months now, and they've experienced explosive growth. They have over 250 telescopes housed buildings with those retractable roofs. At night, the roofs roll off and expose the telescopes that are in each one of those buildings. And my telescope is in the first building since I was one of the very first customers. I think I got the last pier in building 1. I'm actually in building 1, Star Front, and right now they've got 8 buildings. They are technically the largest remote observatory in the world by the amount of telescopes. They have, I believe, just over 250 telescopes that are set up, active, and live at this observatory. Again, there are the pictures. There's well over 100 telescopes in that view alone. And this is a drone flyover of the buildings there. You can see those poles, those black poles are the piers where the telescopes are mounted onto those piers. And then they're housed there. My telescope is mounted on one of those piers, and it's connected to they have a fiber high-speed internet in all the buildings. They've got the technology that allows people like myself to remotely access my telescope. Now, what is unique about my setup with Starfront is the fact that I'm using the ZWO's Seestar S50 telescope, which is a new telescope. It's a new breed of telescope. It's a telescope that's referred to as a smart telescope. It doesn't have an eyepiece. It's very small, very compact. And you see these tubes; those are traditional type, visual tubes or optical tubes that are used for astrophotography, and they're much larger, much more expensive. One of those rigs that start from the typical setup with telescope and camera and remote computer and everything, it could be anywhere from $5,000 to $10,000. My telescope that I have set up at Starfront cost me $500. So I have a $500 telescope for taking images, like this, like the Pleiades star cluster, and over here in the M79, the globular star cluster. We're going to switch here from M79. Let's go to something else. So I'm going to now, let's see, what's a good image that I can point to in Texas. Let's go to an open cluster, M103. So this is the dashboard of the Seestar in Texas. This is what the little scope looks like. It's mounted on a pier. It's only about maybe a foot high. It has a motor that compensates for the rotation of the Earth when the lens is looking at a target, have it pointed at a target. It will move very slowly as the Earth is turning. It will keep the target in view and stay focused on there for hours. I've set it up to shoot an image at 9 o'clock at night and let it sit there all night till 6:30 in the morning. And I wake up in the morning and take a look at the images that it's taken, and they're spectacular. So now I'll just go to here and look for M103. So I'll go up here to the Sky Atlas and put in M103. 103. Oops, that's M103. And this is an open star cluster. Right now, it is in the northwest at about, little over 30 degrees. It's about like 36, 37 degrees. And then I just tell it to locate the target. And right there, the red box is the area where the camera is going to focus on right now. And I will tell it to go to that target. And right now, the you can see it. This is a sky atlas. It's showing um, uh, the parameters there of the night sky. There's Mars. This green line is the meridian right there. This little blue dot is representing the lens of the scope. It's moving over to this red dot. It will meet this red dot over here in Cassiopeia, the constellation of Cassiopeia. That's where M103 is located. And then we're going to see it now start to focus on this open star cluster. This little telescope is rather amazing. The technology that is housed in this little unit up to about 3 years ago uh, was anywhere from $5,000 to $10,000 for this technology. But with everything moving so fast, the software improving, the hardware improving, becoming more affordable, the technology becoming more efficient, it has allowed people like me to buy a telescope like this. And I did buy one about a year ago and here for the house and was enjoying it very much. And I said, I said to myself, wow, this is amazing that I have this little telescope. But what's interesting is that I said to myself, the weather in Miami is maybe I'd get 2 or 3 nights a week that would be clear enough to take the telescope outside to start imaging some things. More often than not, it would be cloudy. And then what happened, I was just saying to myself, there's got to be a way that I can hook this up or send it someplace where it's, better weather, clearer skies, darker skies. And lo and behold, in June, I came across a video by Bray Falls, which is the main guy over at Star Front Remote Observatories, and he was talking about he's going to open up a remote observatory, and they bought the land. They set up the two buildings. They started setting up some telescopes there, and it just took off like wildfire, mainly because they made it extremely affordable. That is something that I really commend them for, because this is something that has been only available to wealthy people. That's the way Bray Falls put it. He's worked at some of the most prestigious remote observatories in the United States and around the world, and it costs minimum $1,000 a month to house the smallest telescope. Here at Starfront, they've got rates starting at $99 a month to host a telescope. So we've got a bunch of people that everybody's on here. We've got Danny, we've got Anna, we've got, I don't know who else will be joining us here soon, but we've got the Pleiades star cluster. This is the telescope here in Miami, and we'll switch over to there, Texas. There's the M103, the little star cluster. Let me see if I can zoom in on that. There. It's a tight little star cluster. There are many stars. There's a yellow star in the middle. If you could see that, there are some blue stars around it. But we've got that going on, and we've got a lot of other things, going on in that picture there. There are many, many stars around it. I'll zoom back out there, and you can start to see. As I let it sit there, it's taking 10-second exposures right now, 10-second pictures, one on top of each other, and able to get so that we can get a resolution, a high resolution picture. And the longer I let it sit there, the more 10-second exposures it takes, and then the more definition will be available to us in the image. You can see a lot of stars in the background. After another 10 minutes, you'll start to see more and more stars in the background. If I let it sit here for a couple of hours, you'll see thousands of stars. And this is a tiny, tiny little piece of the night sky. It's really something, if you were to look at it, it's only about an area less than 1 inch by 1 inch in the night sky. And and you could see just in this picture alone, we could see hundreds of stars right there. And actually, there's thousands, if not tens of thousands of stars in this view right here. But getting back to Starfront made it possible for me and a lot of other people to send a telescope to Texas in a very dark night sky. There's people that have sent their telescopes that live in Japan. They live in Asia. They live in Europe, Canada, South America, many different parts of the world, and they've sent their telescopes to Texas. They receive the telescopes there, they set them up, install them, connect them to the internet, and make it so that you can log in to the telescope with, like I'm using Google Remote Desktop to log into my telescope and control it remotely, and it works perfectly, just as if I was controlling it here in Miami. I am controlling this telescope here from Miami. This one is actually in the patio in the backyard, and this one is live. So I've got this one here, but it's the same thing as having the Seestar in Texas on this view here. So I've got, this is Seestar Texas, Seestar Miami, and going back to the Pleiades, you can see that haze building around this star. This is the one with the most nebulosity here. This is a beautiful haze there, and it's a great image. I'll show you an image of this this target when I've processed it and I've let it sit there for over 4 hours. It will look something like this. That is the final result of the Pleiades star cluster after about 4.5 hours of 10-second exposures. You could see this beautiful blue nebulosity around the stars. It's something really spectacular. No wonder this is one of the favorite targets in the night sky for astrophotographers and even visual astronomers. You can see this very clearly, even with a pair of binoculars. If you go out and you're in a dark area, and it's a new moon where there's not a lot of moonlight, you can actually see this, and it's very, very beautiful to look at. Really enjoy looking at this target in the night sky. So there's the result, high resolution picture, and this is the raw live image that we're looking at here from Miami of the Seven Sisters Pleiades star cluster. Let's see if anyone else has joined us on the chat here on the YouTube live. Let's see here. Where is that? Over here. Okay. Okay. Yeah, we're looking at these things here. So the star cluster here. I'm going to move Texas to something else. Okay. The little star cluster is great target. Let's go. Let's look at Jupiter. Let's look at the planet Jupiter, though we're not going to see a high resolution image of Jupiter. We should be able to see Jupiter and some of the Galilean moons of Jupiter. Let's see. I'm wondering if, so I know I posted this on Instagram, and I'm wondering if there's any messages that are coming in from Instagram about this. We did make a post on there, and let's see, we go here, solar system, and from the menu there's Jupiter. That's a beautiful picture of Jupiter. That is not a live image right now. It's at a very high, it's very high, almost directly above us. It's in the zenith. I'm going to tell it to go gazing, and it's now moving the telescope in Texas towards Jupiter, and we should be able to see Jupiter here momentarily. Should appear as a one bright little light, and then 3 or 4 smaller lights or stars. They almost look like little stars around the main planet there. We won't be able to see the rings or the brown parts, the brown bands of Jupiter, but we will be able to see the Galilean moons. Galileo was the first person back in the 1600s with his crude telescope that he had invented, was able to look in the night sky and look at Jupiter and actually identify that Jupiter actually had moons revolving around it. And that was, he was the first human to have ever done that. So here we've got Jupiter. Let me zoom in a little bit. You can see Jupiter in the middle. This is one of the moons here. It's another one, a faint one, very there. There's one right next to it on the right side. It's really right next to it. I'm not exactly sure which one that is. It could be Io, could be Ganymede. There are four of the moons that are Europa, Ganymede, Io, and Callisto. I only see two there and one right next to it. Actually, now that this is resolving, I actually see two that are very close to each other. These two guys. Okay, those two right there. So those are one, two, three, and then if you could see right to the right of it there, there's one of the other moons of Jupiter right there, and those are the main four moons that are most visible on this view right there. If I look up in Stellarium, let me look up in Stellarium over here and see what the positions of those moons are right now. So if I go to Jupiter, we can look up Jupiter. This is a great piece of software that allows you to look up anything in the night sky, and I can zoom in as I'm zooming, and as I suspected, that one that's in the bottom there is Io. Then over here, a little bit further out, we have, let's see here. Okay, Ganymede at the top, then Callisto, and Io is the one that's closest to the edge right there. So this is an amazing software. This actually shows real-time positions of the moons of Jupiter or any planet that has moons that move. Can actually be identified with this software, Stellarium. You can get a free version or go to the website, stellarium-web.org, and it's a free application. If you're into astronomy or just curious about the night sky, this is a fantastic tool. It gives you a lot of information about everything, star clusters, planets, nebula, galaxies, everything on there. So we can zoom out again, and then we could see there's Jupiter at the top, there's Ganymede, and there's Callisto. We'll go to the live view in Texas, and let me zoom back out there. And that is Jupiter right there in that view. So if I can zoom in, let's see, do a 2x zoom. Let's see what happens here if we go 2x zoom. It's going to zoom in a little bit, actually, and it's going to appear fuzzy, but okay, there's a tighter view. So you can clearly see right there, that's Io, right to the right of Jupiter. Here is Ganymede and Callisto. I don't know where Europa is. Europa could be further out. Let me go back to Stellarium and see where is Europa. Europa sometimes hangs out pretty far. Let me see. Is it down here someplace? Nope, not seeing it there. Could be behind Jupiter right now. In fact, I think that it is. It's showing there's an image like a little round circle there on the edge, which could be Europa. It could be in front of it, actually, and could be casting a shadow from the sun being behind it, the shadow of Europa on the surface of Jupiter. And I've seen that through a visual telescope. That's very spectacular. That's something that's pretty amazing to see. But Jupiter is the largest planet in our solar system. It has many, many moons, more than four, has over 80 moons. Many of them are deformed rocks or asteroids. that are in its kind of permanent orbit, so they're classified as moons. And let me go back to the live stream. Then, hello, Olga. How are you? We've got the Seven Sisters over here. This is the Seven Sister Star Cluster. This is a telescope from Miami. We've been on this target now for about 22 minutes, and it's coming along very nicely. You can see the nebulosity building up around these stars there. It's a beautiful star cluster. Really highly recommend it. If you've got access to dark skies, or even in your backyard, and it's not too lit up and it's kind of dark, you can go out and look up. Right now it's kind of, if you look up to the north, well, I would say almost like straight up, but to the west, you will see the Pleiades star cluster. And tonight it's pretty clear here in Miami. So if you're in Miami and you're kind of far away from some lights, it's a dark out. The moon isn't going to rise till about 1:30 in the morning, and the moon right now is less than 30%. So this is the best time to the darkest time is when the moon is in a waning phase. When it's waning, that means the moon is getting dimmer in its light. When it's waxing, that means that it's increasing in its luminosity, in its light, the amount of light that it's reflecting from the sun. Astronomers and people into this hobby, they like the moon, but it's a love-hate relationship with the moon. The moon is beautiful and everything, but for about 12 to 14 days a month, it's a pain for astrophotographers because it illuminates the night sky, and it's very hard to image dim objects. Unlike the Pleiades cuts right through. These stars, they're so bright, they cut right through the moonlight. They can even cut through some faint clouds. They're so bright. But this is a spectacular star cluster that we're looking at here, the Seven Sisters. So that's for you, Olga. Seven Sisters live for you. And let's see what we're at here. Is anybody else joining us here? We've got Daniel, we've got Anna and Olga on here. Thank you for joining us tonight. And if you could subscribe to the channel, looking to get some subscribers here. I'm doing this to try to reach more people with this technology of the smart telescopes and make it available. Sometimes it's hard for people to get out, to go to a star party, to know someone with a telescope, to actually be able to look up in the night sky. You can see some stars, but with these telescopes that I have here in Miami and the one in Texas, I'm able to point them at any target in the night sky and share it with you live on YouTube Live, and you could see these spectacular views of the Pleiades star cluster. And let's go back to Texas. We're looking at Jupiter over here. So there's Jupiter, and I'll see if I can bring this view up a little bit. Okay, there's Jupiter. That bright dot is Jupiter. To the right of it, if you can make that out, I'll zoom in a little bit. That is the moon Io sticking out to the right of it, right there. And then these two are this is Ganymede and Calisto, two of the four moons. Right now, we can't see. I believe Europa is either behind Jupiter or right on top of Jupiter, so we're not able to see it right now. But typically, on most nights, you'll be able to see all four um, moons very clearly on here. The Seestar, a lot of people say, "Oh, can you point it at Jupiter? Can you point it at Mars?" Yes, I can absolutely do that. But unfortunately, as good as this telescope is, and even many more expensive telescopes cannot resolve such a bright target like Jupiter against a black background. All we get to see is, because these digital sensors on these cameras, they see a bright white light. It looks like a little light bulb to a camera, to a digital camera, against this pitch black background, and that's the best it could do. So basically what happens is, people can uh, look at this through a visual telescope, and through my Celestron 8SC telescope, you can see the bands of Jupiter. I mean, almost like you can here in Stellarium. I mean, this is, I can see Jupiter almost like that in my visual telescope. It is that clear. But a digital telescope has a hard time resolving that image, because of the fact that it's very hard. There's a lot of light. It's trying to gather as much light as possible, and the sensor is just focusing on the bright light, and it's not able to resolve all this beautiful detail. You can see these brown bands on Jupiter through my Celestron 8SE very, very clearly. It's hopefully the technology will get better so that we can actually see those features on there. So yeah, that's Jupiter right there, and that's Io right there at the bottom, Callisto, and Ganymede. Europa is right now, I believe, behind Jupiter. In a little while, it'll come out. Jupiter's the largest planet in our solar system, and it's about 1,000 times larger than our Earth, and it spins at a very, very fast clip. Every 10 hours, Jupiter rotates. Here, it's once every 24 hours. Jupiter rotates once every 10 hours. So it's not only huge and massive, but it's very, very fast. And the moons will rotate around Jupiter at a very high rate as well. So it's something that a lot of people don't realize. Jupiter is very, very fast. You could see the red dot. I have an app on my phone that tells me when the red dot is going to be visible on the surface of Jupiter. And it is something that, if you ever get a chance to see Jupiter with the red dot, you could see it clearly. It's the largest storm or the largest hurricane in our universe. It's been active for hundreds of years, as long as we've been looking at Jupiter. Scientists say that it has a width of about 500 miles wide, and this red dot goes around once every 10 hours, and it's visible for about 20 to 30 minutes. You have to catch it at the right time, but it is something just beautiful to behold when you see it in a telescope here. So that's Jupiter there, and let's get off of Jupiter. I'm going to, let me see, zoom back out here, go to a one-time zoom, and we're going to move to another target in Texas. We're going to go to the crown jewel of the night sky. We are going to go to, in my opinion, the most beautiful nebula, bar none, end of story, de facto, take it to the bank. M42, the Orion Nebula. And not many people will argue with that statement, that it is by far. This is the Orion Nebula, also known as Messier 42, is a diffuse nebula situated in the Milky Way. It is in our Milky Way. And it is in the constellation of Orion the Hunter. Now, the people in our Camp 305 astronomy club know this very well. Orion the Hunter is right now visible in the winter night sky. It's a beautiful constellation, and we're going to go to it right now. It's at about almost 60 degrees up in the south sky, and I'm going to hit go to right here, and we are going to now have it sleuth over to the Orion Nebula. This is an image that I've taken many, many pictures of. It's a gorgeous image. It resolves very quickly in any telescope because it is very bright. This target here is one of the favorites because it's easy to find. It's very bright, and it's very, very colorful. So right now, here we go. Look at that. With that, just without a 10 sec, there it is, a 10-second exposure, not even the first 10-second exposure on the Seestar in Texas. And there we have basically the view of the Orion Nebula. And as it takes a few 10-second exposures, you're going to start to see some beautiful color. Look at that. Second 10-second exposure. Just look at that. It's stunning. The color in here is something amazing. I'm going to zoom in here, and you can see this. This nebula is the remnants of a star that died millions and millions of years ago in a massive supernova explosion. And what was left was all this material, all this gas, all this dust that has all this color. You could start to see some like a pink type of a peach color. You could see some like whites and a little bit of yellow coming in the middle there. There's some dark nebula matter over here, and this explosion left behind all this material that uh, left all the components um, of a star nursery: the gas, dust, heat, and hydrogen to form new stars. So this is the center of Orion is referred to as a star nursery. In here is a star nursery where new stars are being born, and there are four main stars that are visible in this bright area in the center of the Orion Nebula that is referred to as the trapezium. The trapezium are four bright baby stars. They're referred to as baby stars, but because they're so young, they're only about 2 million years old. I know 2 million years sounds like a long time. In star life, that's nothing. So these little stars are illuminating this entire area. They are so massive and so bright that they are illuminating this entire area right here, and from the back, so and from the middle. So we're starting to see all this gas, all this dust in here, and they will eventually, over the course of millions of years, move out and away from the center of this nebula, and this dust will spread out even more, and we'll have more stars being born from it. Eventually, these stars will move out uh, to a farther distance, and someday they will use up all their energy, all their hydrogen, and eventually die and collapse in a supernova explosion. Um, Tens of millions of years from now, and then those stars will then leave that that matter and that material there, where other stars will be born. So the cycle of life, as as it is here on Earth, is also a part of the universe. From death comes life. A star dies, it leaves behind all the material for new stars to be born. New stars are born. They expand and grow on to be spectacular stars. And then they eventually run out of their main fuel source, which is hydrogen. Stars are like our sun. Our sun is made up of hydrogen and helium, mainly hydrogen, and that's what is burning at the core of the nuclear furnace that is the sun. And every little star that you see in this nebula is like our sun, but these stars in here are many, many times larger than our sun, and they will burn at a higher intensity. They've got more fuel. They'll probably last longer than our sun, and they will shine brightly for tens of millions of years. So here we have the Orion Nebula. I'll zoom back out there. We've got another star right here in the bottom. I forget the name of this star here, but there's some really big stars in here. This is a spectacular view here. This is in the Sword of Orion. So if we were to look at this constellation, you would see the drawing. The Greeks said, looked up in the night sky, saw this group of stars, and said, "Well, that kind of looks like a man standing there with a club in his left hand, and his right hand is pointing down, and he's wearing a belt, and from his belt is hanging a sword." Well, this nebula is in the sword part um, of the actual um, constellation right there. And you can look at this. You can see this with a pair of binoculars in the night sky. It is spectacular. If I go over here to Stellarium, we're going to go back to Stellarium. We're going to put in here M42, which is the Great Orion Nebula. And then we're going to zoom out here. There it is. Okay. Here is the Orion Nebula. And we can see the three belt stars here. And then the area that we're looking at right now is this area right here in the Sword of Orion. The Orion Nebula is right here in the middle of this, almost like a line. There's actually 1, 2, 3, 4 group of stars here. It's in this group right there, the third group right there, and you have this beautiful nebulosity around those stars. That's what was left after a supernova explosion, a massive explosion, over 2.5 million years ago, and left there. There's so much to look at in that nebula there. There are many stars. There are other nebulas there. If we were to go a little bit further around here, here's Nintaka. This is one of the first stars in the belt of Orion. This is also a very beautiful area. Here's the Horsehead Nebula, and we might image that in a little bit. That is the Horsehead Nebula to the bottom of Nintaka. And then to the top left, you see the Flaming Star Nebula. If I was to go in here and zoom in a little bit more, you can start to see the Horsehead Nebula right here. And if you look at it it's upside down, but it does look like a horse head. A lot of people say, "I don't get it." Well, look at it sideways, and you can see that's like the nose of the horse, the neck right there, and that's a Horsehead Nebula. It's a very, very popular target. And there is the Flame Nebula. I've taken a picture of this. I'll show you this on my website. This is one of my favorite pictures, one of the ones that I'm most proud of here on the on my website at Star Pictures Miami. If you get a chance, definitely go to Star Pictures Miami. Check this out. Here is the image. Where is it? Down here. Okay, there it is. This is a 4.5-hour exposure of the Horsehead Nebula. So there's the Horsehead there. And you can look at it sideways there, but you can definitely see that it does resemble a horse head there. And over here is the Flaming Star Nebula. This is a beautiful, or the Flame Nebula, actually, the Flame Nebula. This is a beautiful, very bright nebula there. This is another supernova explosion from millions of years ago that left all this beautiful dust and gas here that's being illuminated by these stars here. So this is definitely one of the top 5 most photographed nebulas in the night sky, the Horsehead Nebula. So, that's in the belt of Orion. So if we go back to Stellarium over here, there we've got the 3 main stars there, and there's a Horsehead there, and really beautiful stuff. But I'll see if I can actually bring up the constellation art. So the art, you can see the constellation art. Okay, now let me go back to M42 and zoom out. Okay, so there, okay, there is the constellation of Orion the Hunter. If you could see, that's an image of a man there. He's standing or he's kneeling, um, and this is his belt. These three main stars are his belt. Then here is hanging from his belt a sword there. You can see the outline of a sword. And then you can see his head up here. Betelgeuse, very famous star. That's a super red giant star. That is the armpit of Orion. That means actually literally, I think in Arabic it means armpit. And then the other armpit is Bellatrix, which is another beautiful star there on this. That's his left shoulder or left armpit there. But that's the belt of Orion, and that's the sword of Orion right there. And we've got what we're looking at is right there in the sword of Orion. So we'll go back to this. That is the Orion Nebula. That's a live view from my telescope in Texas of the Orion Nebula. Um, just a spectacular view. And I'm going to zoom in a little bit more so you can see this detail. And it's amazing that we can see this. This is over 600 light years away from us. And the fact that we can see this and you can see this with a pair of binoculars is pretty amazing. Look at all this gas and dust. This is only, let's see, not even 10 minutes of an image. This is 8 minutes and 30 seconds of the image of the Orion Nebula. We'll go to Miami. So we'll go back to, here we are. Okay, we're going back to the Pleiades star cluster. And I'll get off this target here in a minute, but I just want to show this nebulosity that's building up around these stars. This is the Seven Sisters, or the Pleiades. This is an interesting target. Little factoid about this star cluster. If you've heard of Subaru, the car company, the Japanese car company, Subaru means Pleiades in Japanese. So next time you're at a red light behind a Subaru and you're looking forward at the logo of a Subaru, you're going to notice it has stars in the logo. And there's actually 6 stars, not 7. The reason there's 6, because for many years, it was thought to have 7 stars. But as we had better technology and better telescopes, we were able to get a view like this and able to determine that there are actually, this up here, these 2 stars at the top were thought to be 1 star. It's actually considered maybe a double star, but it was often viewed as 1 star. So that's why they counted 6 stars in it. So they saw like 1, 2, 3, 4, 5, 6 down here. And in reality, they were able to resolve this in like the 1800s. They say, oh no, that's not 1 star, that's 2 stars. So it's actually 7 stars. So you'll see the logo of a Subaru, and that's this star cluster on the back of a Subaru car there. So yeah, that's the Seven Sisters there. And then okay, we've got enough of the Pleiades. We're going to go somewhere else here from Miami. We're going to go and let it sit on let's go to Andromeda, the Andromeda galaxy. Spectacular galaxy here. We're going to go into stargazing here. We're going to go to M31. Is it still available? Let's see, M31. We'll go to the Messier catalog, and we'll go to M31 and make this telescope. Let's see if we can resolve Andromeda here from Miami. Hopefully it can. We'll find out. If not, I'll switch Texas to it. But Andromeda is the kind of the sister galaxy of our Milky Way. It's scientists say it's very similar in the size and scope as our own Milky Way. Andromeda is a galaxy that is about 2,000 light years away from the Milky Way. Scientists say that we, in about 2.5 billion years, we will collide. Where Andromeda is in a collision course with the Milky Way. About 2.5 billion years, they will merge together as one massive, massive um, galaxy. Here, you could already start to see it, the heart of it, start to form right here. There's a little haze on the screen. Give it another 10-second exposure, and you will start to see the bands. Okay, there. Now that's becoming a little clearer. As it takes another 10-second exposure, you'll start to see it kind of diagonally start to form the the bands of Andromeda. This is a massive galaxy. There are billions, if not trillions, of stars in this galaxy of Andromeda. It has a lot of gravitational pull. There are many black holes that are being discovered in Andromeda. There are black holes being discovered in our own Milky Way, but in Andromeda, this is a target that is probably, again, top 10 most viewed and studied and imaged targets in the night sky. It's also very bright, not as bright as Orion, but very bright in its own way. I believe it's about a mag 6, magnitude 6. Orion is a 4. The lower the number, the brighter the target is, and so anything below a 6 is very bright. So Andromeda is a 6, and Orion's a 4. There are targets that are 2. Stars are so bright that are minus, like, for example, Sirius, my favorite star, that's like a -3 on the magnitude scale there. But we've got now Andromeda forming in the view right there. And we'll let it sit there for a couple of minutes, and then we'll come back to it. But Andromeda is spectacular. We'll look at Orion there. Let's look at Andromeda on Stellarium. And we'll go to M31, which is Andromeda Nebula, galaxy. To me, it's more like a galaxy. That's what it will look like. And what we have here, if you notice, there's a lot of things here. There's another galaxy, M110 is another spiral galaxy. M32 is a much smaller galaxy that's being sucked into Andromeda. Andromeda's gravitational pull is such that it is actually absorbing, these other smaller galaxies, which are gargantuan in their own size, but they are being drawn into the center of Andromeda. This will be our Milky Way in about 2.5 billion years. It will be drawn into the gravitational pull of Andromeda, and we will actually see this in Texas here. Let me go. Okay, there's Andromeda resolving right now. This is the scope in Miami in my backyard right now. So this is a live view of Andromeda. That haze around there is not just dust. Those are millions upon billions of tiny little stars in this massive galaxy. So, if we think we're big and the Earth is big, we are, like Carl Sagan said, but a speck of dust or a speck of sand on a beach that's 1,000 miles wide. We're a grain of sand on a beach that's 1,000 miles wide. That's how big the Earth is in relation to everything else in the universe and anything else in Andromeda alone. And Andromeda is only one of billions of massive galaxies here in the night sky. So we've got these two beautiful targets. There's, going back to Orion, there's Orion. Gorgeous view there. I'm gonna see. Let me go see how many people we've got here on the live stream. So Olga and Danny, and we've got a couple other people there. But yeah, so that's what we've got. If anybody's got any questions or anything like that, they can post them on the chat. And I'm gonna switch Texas back to another target here. That's Orion there. Let's go to let's see, let's go to a star cluster, another beautiful star cluster in Texas. We're going to go to, let's see which one from my list here. NGC 2362. NGC. That means the New General Catalog, which is not new anymore. We're going to stop that and we're going to zoom out. NGC 2362. And we're going to look at this beautiful star cluster in the night sky. We're going to go here. We're going to look it up here in this Sky Atlas, NGC 2362. And then we're going to tell it to go there. And there is this star cluster. I'm going to draw a little box around it, frame it up a little bit better so you can see this there. So that's what we're looking. We're going to look at this star cluster right there. We're going to tell it to go to NGC 2362. Go to. This is a very bright star cluster. You'll see the stars almost immediately. And the blue, here's the telescope coming, and it's in Canis Major. This is in the Orion's hunting dog, Sirius, the main star of Canis Major, but Canis Major's dog. This is the big dog of Orion the hunter, and we'll be able to see this constellation, or this group of open cluster of stars here momentarily. NGC 2362. It's got a lot of very tight stars in there, very, very bright stars. You'll see, and it's a beautiful little cluster of stars. I like these clusters because they're easy to resolve. They can actually be seen quite easily with the Seestar and even with any visual telescope. See, right now it's moving, and it looks like you see Star Wars. You see the stars like moving very fast when they go into hyperspeed. The telescope is moving right now, and we're seeing these star trails. But in a second, it's going to stop moving, and we should see this cluster resolve very nicely here momentarily. There, it's starting to come into view. It's a little bit off center. It's more on the left side. And as it takes another image there, we'll see that resolve. This is let me see, 2362. I'll pull that up on Stellarium. NGC 2362. So there's Andromeda. And some interesting things about Andromeda, these two galaxies that are being drawn into it right now. Let's see where we're at. Andromeda here in Miami. There's Andromeda right now. Starting to see a little bit of a dust lane forming right here on this. It's a very, very big target. There's a lot of light pollution here from Kendall. Maybe not as good a resolution image as from Texas, but from Texas, this is a little bit too low on the horizon, so I'm not able to get a good image of it. It's too low. It's actually would be blocked by the wall of the building where the telescope is housed, so I would not be able to get a good image of it, or not be able to see it at all. And that is Andromeda right there. So we'll go to Stellarium and look at NGC 2362. So we go NGC 2362. There's an open cluster. NGC 2362, also known as Caldwell 64, is an open cluster of stars in the southern constellation of Canis Major. It was discovered by the Italian astronomer Giovanni Battista, who published his finding in 1654. So if you can believe this, people back in the 1600s were looking up through telescopes that that Galileo had invented, and they started copying his design and looking up at the night sky, because I believe he invented his telescope in like 1640, and revealed it in Venice, Italy, in 1640, and made a big presentation about it, and then revolutionized astronomy forever. But this guy Battista in 1654 was able to look in the night sky and see this star cluster that we're looking at here. So this is a magnitude 4 star cluster. You can kind of see it's a lot of stars in there. We'll go back to it and see the live view of it over here. That's that star cluster right there. So we'll zoom in right there. And these star clusters are groups of stars that scientists believe that they were born together in a nebula, and that's why they're so close. And over millions of years, they will start to separate and spread out. They spread out very, very slowly. But people think that stars move. Stars, they move, but very slowly, and take millions of years for them to position themselves. But oh, there's Andromeda. Yeah, it's coming in. It's a little bit low on the horizon and to the west. It's kind of dark here from my house. It's not as light polluted as it is to the north, but we've got Andromeda there. And let me see. Go back over here. All right. Yep. So I can send some of these images. I'll post some of these images on this so you guys can take a look at them afterwards. And please let your friends know about this with Star Pictures Miami. If you can like my YouTube channel and subscribe to it, that way I can inform you about upcoming videos and YouTube live events like this. I'm doing these what I call online star parties. Like last night, I was out in the Everglades with Anna, and we set up the telescopes out there, and it was a lot of work to go out there, and then it was cloudy, and that's just the reality of this hobby. You'll go out there thinking that it's going to be clear. It ends up being cloudy, and you spend an hour going, you're driving, and another hour coming back. The time, the gas, and the effort, and everything like that. And I can bring this to people right in the comfort of their own home. They can be watching this from their smartphone or their laptop computers, and it's something that I want to share with more people, because it's something that is really beautiful and very interesting to be able to look out in the night sky and learn about so many things that are out there. There are many things we are just but a grain of sand in a beach 1,000 miles wide. That's to repeat Carl Sagan. We have a lot of things to learn about our universe and everything about us. But yeah, that's the star cluster there. So that's what we've got for tonight. If anybody's got any questions or anything like that, you can send them to me, starpicturesmiami@gmail.com. That's starpicturesmiami@gmail.com. And I'll be having other star parties online here in the future. And hope to see you guys back soon. If somebody is interested in astronomy, please tell them about this channel on YouTube, Star Pictures Miami. I post a lot of images from Texas here, videos, and things like that are, pretty special things that we are not able to see here from Miami, that I can see from my telescope in Texas from a Bortle one night sky. So it is something pretty special. And if you have anybody that any kids that are interested in astronomy, or if there's anybody that has a telescope and is looking to associate themselves or get to know a group of people into astronomy, Southern Cross Astronomical Society is a great group that I belong to. And we meet for our star parties every Saturday. We have membership positions available. It's only $50 a year to become a member of Southern Cross, and it's a great way to support a local group we're doing a lot of outreach to the community and schools and Boy Scouts and Girl Scouts and things like that. about astronomy. So thank you for your time. I really appreciate it. And go out and take a look up at the night sky, and enjoy yourself. Thank you. Have a great night.